Is this visible?
Yes, sir.
Okay, so what we did in the last class is we started from here. Application of Bohr model. Not, I think we started from here, right? Bohr atomic model yesterday, yeah, 19. So we said Bohr model is based on the quantum theory, applicable for the single electron system, and based on the particle nature. And there were many postulates. More important is electrostatic force is equal to centrifugal force and angular momentum. These were the two important things. Based on this, we could calculate the radius of the shell, velocity, and energy. These three are the most important, and we use this uh, like very frequently. And last point was different type of energy. One is the ionization energy, separation energy, and excitation energy. Okay. So if we are done with it, we can start a new topic. And today's date is 2012 and 2025. Okay. And make sure you write all the question, including summary, and I'll check in the end of the session. So write everything. Spectrum. And I'm not just talking about the electromagnetic spectrum, in general spectrum. Correct? So when any radiation passes through the prism, in the optics chapter, dispersion of light. So it will disperse and there will be pattern form. And this pattern of the radiation is known as the spectrum. Correct? So this spectrum is related to the given radiation. If you pass a specific radiation through the prism, then there will be spectrum. Here spectrum are two types. One is emission spectrum. When energy is released, then you will have emission spectrum. And second is absorption spectrum when energy is absorbed. Correct? So spectrum formed in two situations. One when energy absorbed and when energy released. Correct? Because in Bohr model, we were talking about the hydrogen or single electron system. That's why in this situation, we'll talk about the hydrogen spectrum, single electron system. It means electron will be single. Okay, you will have only one electron. How this one electron get excited and move to the different shell? That is what we want to study. Okay, example: when any electron get excited, then some kind of light will be emitted. Correct? If we pass the light through the prism, then spectrum will form. Correct? And we want to study this spectrum. What will be the wavelength of this spectrum? Does it lie in the visible region? Because if it lie in the visible region, we can see the color pattern will be given. If it is not visible region, we can't see. Any doubt in this?
No, sir.
Okay. So when any electron get excited, some light is produced. This light, when passed through the prism, then spectrum, and that is when we talk about the hydrogen spectrum, or in general, spectrum is always like this. Okay, any specific energy is released or absorbed. When this energy is or radiation is passed through the prism, then seven color or different spectrum of the energy will be formed. Correct. Example, you have electromagnetic spectrum, so different type of radiation is produced. So what kind of line you will see in the spectrum is known as spectral line. So what is a spectrum line? Line formed in a spectrum. And these line can belong to the different uh, type of series. That's why we have total 5 series. So I'll make a table. First is the series, and you know 5 series: Lyman, Balmer, Paschen, Brackett, and Pfund. Correct? Based on the scientist name. Second, in which region it is produced? Does it belong to UV region or visible or infrared or anything else? How it move from one system to the another system? Like example, when electron move from the high energy to the low energy, it will release energy, correct? There will be emission spectrum because most of time we talk about emission spectrum only. So what is the meaning of emission spectrum? Example, an electron, this is nucleus, and here you have first shell, here you have second shell. So electron was present in the example second shell and value is 2. When this electron come to the first shell, then it will emit some radiation. Some radiation will be produced when it move from second to first. And this radiation will be passed through the prism and some kind of line will form. That is the spectral line. Spectrum forms, spectral line is formed, and you can see number of line in this case. Any doubt, guys?
No, sir.
Because remember, you will never face issue in the name. There are 5 series and what is their name, what is their reason. It is easy. Where you will face difficulty, what is the basic meaning? If examiner twists the question, how we can answer that? Example, first you have Lyman series given by the scientist Lyman. It lie in the UV region. Energy is very high in case of UV region. Okay. In this case, you will see कि electron will move from second, third, or fourth to first region. N1 is first. This is N2 value. So it can move to the first orbit from any of the orbit. We don't care which orbit. Okay. And what is the number of line form here? One. How lines form? I'll tell you later. Second is Balmer series. So energy will be slightly less than the Balmer series, sorry, Lyman series, and it is visible region. Remember, you have maximum energy in case of Lyman. Every time it will keep on reducing. Okay. So here electron will move to the second shell. And if it is moving to the second shell, at least it will come from the third or anything higher than that. Ask me if you have doubts. Okay. If electron is entering into second shell, it will come from the higher shell. Higher could be third, fourth, 1000, we don't care. Understood? It is coming into the second shell. And number of line is formed accordingly.
Sir, I'll
If you
just come
see,
in 2 minutes.
okay, third series is Paschen. Paschen will have less energy. For this, you should know if you take energy or Sarah, am I audible?
Yes, sir. Yes.
Yeah. So if I take energy or frequency in electromagnetic spectrum, you know maximum is gamma, next X-ray, next UV, next visible, next infrared, next microwave, and last radio wave. Okay. So this is electromagnetic spectrum, correct? This is electromagnetic spectrum. Any doubt? If here you compare these three energy, then UV have maximum energy. After UV, you have visible region. After visible, you have infrared. So remaining all the series will be in the infrared region. Infrared region. Here, electron will move to the third shell. If it move to the third shell, it will come from the higher level, and higher level could be anything more than 3, 4, 5, 6, anything like that. Number of spectral line 3. Fourth bracket, again infrared. Electron will move to the fourth shell, then it will come to the higher position. What could be the number, Marinder?
5, 6.
Yes, anything but minimum 5. And Chandana, what will be the number of spectral line?
4, sir.
4. Next is bracket Pfund. Again, it is infrared. Sania, what will be the N1 value?
So it will be 5.
5. Sarah, what will be N2 value in this case?
So 6, 7.
Minimum 6, anything more than 6. And who, whom I missed? Sania, Chandana, Brinder. Anvita, are you there?
Yes, sir.
What will be number of lines in this case?
5.
Number of 5. Okay. Many coaching institute will tell you more, but NCRT mention only these 5. So we will keep it 5. Some people teach Humphrey 6, but no need. This is the series where you see which radiation is produced in which region. There are some data you can correlate key here. Last 3 radiation are produced in infrared, and sequence is according to the energy. Highest energy in Lyman, then Balmer it will reduce, and then infrared. Same, according to this series, their N1 value will be different, and number of spectral line will be according to the N1 value. Okay, number of spectral line. So you should remember this sequence L, BP, BP. Do you know any name that start with L? Lokesh. Lokesh always talk about BP and only BP. So BP, Balmer Paschen bracket Pfund. Balmer Paschen bracket Pfund. You can make your own also. If you make, let me know if anything I feel it's good. We will add in our notes. I'll add in the future classes also. Any doubt?
No, sir.
So now you can compare like how it is produced in the different region and number of the spectral line. Okay. And based on that, there will be different kind of spectral line. Example, if you have different type of the, what should I say, shell or orbit. Example, if it is, if this is first shell, I'm calling it not IM, it is always K. Second, L. Third, M. Fourth, N. Fifth, MNO, and it is keep going on. Correct? If electron come from the second thing, so it will look like this. Second to first, there is only one line. Correct? And in this case, if you see almost from the every situation, electron can come. Correct? It can come from the third to first, or fourth to first, or fifth to first. Correct? This is the Lyman series. Electron can move from any shell to the first shell because we are bothered about N1 value, which is 1, and it will lie in the UV region. Same way, if you compare in the visible region, N2 value, uh, this is 1, 2, 3, 4, 5 number of shells. If you see Balmer series, all the electron will land in the second shell, whether it is from third or fourth or fifth, like this, right? This will be Balmer series. Same way, if you take Paschen series, then uh, it will come either from the fourth or fifth, like this. Make sense? This is Paschen series. This is how radiation work and energy work. Let me ask question from the yesterday's topic. Chandana, what will be the energy when this value is 1? I will write it properly. Here you have 1, this is 2, this is 3, this is 4, this one is 5. If this is the situation, Chandana, what will be the energy in first level? Chandana,
So Z value is 1 or no?
yes, you have to take for the electron. Minus 13.6 because N value is 1, Z value 1.
Yes, sir.
Barinder, what will be E2 value? What will be Z value? Always 1. What will be N value in E2?
So
Barinder,
2.
no, N value will be 2, correct? What will be total energy? You will divide 13.6 from 4. Why? Because energy is equal to minus 13.6 electron volt Z square by N square. Z is 1. So energy will be 13.6 N square. In the first situation, N value is 1. That's why minus 13.6. If N value is 2, you divide by 4. Answer will be minus 3.4 electron volt. Sarah, in case of E3, what will be the value of energy?
So
Which number you will use for the
minus
in numerator? Minus 1.51.
1.51.
Yes. You will divide by 9 because N value 3, N square value will be 9. Sania, E4. Tanya, is this correct? If like calculation is taking more time, at least you can tell, sir, n square value will be 16. Okay, Sania?
Yes, sir.
Anvita, E5.
So I'm a little confused. Like, can you explain once more?
Yesterday we did this thing, energy of any orbit will be minus 13.6 z square by n square. We are calculating all these things for hydrogen. That's why z value is 1. Now we are changing n value and calculating energy. We are changing n value and calculating energy. Example, here E1 means n value is 1. Then it will be 13.6. E2, n value will be 2, you will divide by 2 because it inversely depend upon n square. Same way 3 square, 4 square, what will be value of E5? You will divide by 25. Why? N square. N value is 5, n square will be 25.
Got it.
Okay. So in the first case, we are dividing by 1 square, second 2 square, third 3 square, fourth 4 square, fifth 5 square. Okay. Sometimes we have to calculate difference between them. Example, Sania, what is the difference between E1 and E2? Final minus initial, E2 minus E1. Okay. It will be positive. Why? Final minus initial. Initial is more negative. That's why it will become positive.
Yes, sir.
Same here. 1.51 minus 3.4. It will be 1.89 electron volt. Same here, same here. You can calculate the difference. Okay. So we did same thing yesterday. Now we'll get some word, and these words are extremely important for the coming topic. If you say there is the first line, it means is starting line, and starting line or initial line. When you calculate for first line, starting line or initial line, different word, remember in this case, energy will be minimum and wavelength will be maximum. Energy will be minimum and wavelength will be maximum. I'll show you. You just keep observing it and later on I'll show you. Okay. If you take the last line, then in case of last line, it is also known as limiting line. This limiting line is also known as marginal line. In this situation, energy will be maximum and wavelength will be minimum. And tell me, none of you understood this. What is the meaning of this? Energy will be maximum and wavelength will be minimum. And you are like, sir, what are you talking about? We have no idea. Example, if you see in this situation, if you, it is first line, if it is coming from 2 to 1, You see energy difference 10.2. Okay, I'll show you and I'll draw this again only for this small part. Example. I am talking only about the Lyman series. In Lyman series, and one value is always one, and two value can vary. It can come from 2, 3, 4, 5, or anything else like 6. Okay. Example. If you calculate the line is coming from the only second, then such line is known as first line. Understood, guys? First line means came from the minimum number. If you have an n1 1, then
Sir,
n2
can you
should be 2.
explain once more?
Yes. So first line meaning is if you have fixed n1 value, n2 value will be just one extra. Example, in case of Lyman series, n1 value is fixed, that is 1. If radiation come from n2 is equal to 2, then there is a minimum difference. This line is known as first line. I'm telling you again. If line comes from the minimum distance, you will call it as first line. Okay. The simplest meaning example, you are the person. You are like teacher. Here you have first student, second student, third student, fourth student, fifth, and sixth. What will you say if you want to call first person and you want to check their notebook? You will say, "Ki first person, come and bring your notebook and I'll check it." If last person come, you will say, "Ki last person, come, bring your notebook, I'll check it." Make sense? If first person come, first line. If person come, last line. If fifth person come, fifth line. As simple as that. Any doubt? Make sense?
Yes, sir.
From where it is coming. If it is coming from the closest, first person is coming here. Example, out of this line, if last person or last orbit produce radiation, it will be the last line. Anybody have doubt in this? First
Yes,
line and last line. What is the meaning of this? Okay, if line comes from the first row, because we are talking about this. Okay. After this, what is the first row? Second one. This is the second. This is the first row. If line comes from the first row, first line. If line comes from the last row, last line. This is not complicated. What is really complicated? Energy and wavelength. How this energy and wavelength change. Imagine, if you consider first line, I will change this. I will keep it here. Uh, So, you know energy difference between these two is 10.2 electron volt, right? But if you say energy difference between first and last, what will be the energy difference? How many lines are there? 1, 2, 3, 4, 5, 6. What was the energy of this sixth? E6. You will divide by 36, correct? And 36, it will be around zero point 0.3 something, approx 0.3. So what will happen here? Energy is 0.3 electron volt minus. Here energy is minus 3.4 something. Where you have more energy difference? First line or last line? Where you have maximum energy difference? First or last line? Because it is minus 13.6. This is minus 3.4 and this is minus 0.3.
The last line.
Last line energy difference will be approximately 13.3. And in first line energy difference will be 10.2, which is more. Last line. That what we said here. The energy is maximum in the last line. And whenever energy is maximum, wavelength will be minimum. How do we know? Because we know E is equal to h nu or C by lambda. Wherever you have more energy, less wavelength. Tell me, guys. ಅರ್ಥ ಆಯ್ತಾ?
ಆಯ್ತು ಸರ್.
ಆಯ್ತು sir.
ಆಯ್ತು. Any other person? ಅರ್ಥ ಆಗಿಲ್ಲ?
Sir, I will be back in 5 minutes.
Okay. Anybody have doubt in this?
Oh, sir.
ನೋ
No,
ಸರ್.
sir.
Yeah. So this is really important. First line and last line you will understand. If it is coming from the first person, first line. If it is coming from the last person, last line. As simple as that. But the point is where you will have maximum energy and where you will have maximum wavelength. Because in first situation, if it is come from the first line, energy difference is minimum. And whenever energy difference is minimum, then wavelength will be maximum. Correct? Any doubt?
ನೋ ಸರ್.
And you must be asking, sir, is it really important? Yes. When you will solve 1 by lambda r 1 by n2 square minus 1 by n1 square, na? Maximum question you can solve even without using formula and calculation. Just based on whether it is first line or last line. Okay. So first line of any series. First line of any series is known as alpha line. Same way, second line of any series is known as beta, and third line of any series will be gamma, and you keep on going. Okay, this is how we use name in the lines alpha, beta, gamma, or 1, 2, 3. How to calculate the spectral line? Number of spectral line. How many line will form? How to calculate this? You need to understand from where it is coming and ultimately where it is landing. Based on this, you can calculate from where it is coming and to where it is landing into n2 minus n1 plus 1 divided by 2. This is one of the easiest formula where you can calculate total number of lines. Okay? Total number of lines. Any doubt?
ನೋ ಸರ್.
Example. Within the Lyman series, value can be different. Example. If you take Lyman series, In Lyman series, n1 value is 1. Example, if n2 value is 2, because at least it will be 2, then what will be the total number of spectral line? What will be the total number of spectral line? N2 minus N1, 1. N2 minus N1, 1 plus 1, 2, divided by 2. What is the number of spectral lines? This. But spectral line can vary if you take, this is fixed, N1 is 1, but N2 is 3. What is will be the spectral line? 3 minus 1, 2. 3 minus 1, 2 plus 1, 3. Right? Any doubt?
No, sir.
No, sir.
And how? Let me show you. Example, this is N1 is equal to 1. This is N is equal to 2. This is N is equal to 3. If you take from N2 to N1, if you take N2 to N1, you will see that there will be only one line. No other line is possible. As simple as that, right? But if you take from N3 to 1, what are the possible? It is possible from 2 to 1, 3 to 1, and 3 to 2. Tell me. Make sense? That is what we are talking about. How many lines will form here? Because number of line will decide that how energy will be produced by any atom. Correct? Example, how a bulb glow, how LED glow is based on this phenomena only. If same thing happen in N1 is 1 and 2 is 4, what will be the number? First, see their difference. 4 minus 1, 3. Take one more value, divide by 2. 6. Let's see here. 1, 2, 3, 4. One line, two line, three line. Then two line, three line, and this. How many lines are there? 6, na?
Yes, sir.
Like how total number of line come from 2 to 1, 3 to 1, 4 to 1, 3 to 2, 4 to 2, and last 4 to 3. Like this. This is how you calculate.
Sir, but that is not belong to Lyman series.
No, it will be Lyman series because ultimately N1 is 1, na? Correct? It could be anything. Lyman series, when we said 1, na, in this series, here, we are considering this when it is coming from 2 to 1. Understood? We two lines if it is coming from 3 to 2, like this. If it is coming from 4 to 3, 5 to 4, and 6 to 5. Then any doubt?
Sir, it should come to 1. No?
No. In Lyman series, it should come to 1, but here when we said number of lines, na, then uh, in this series, we are considering only from 2 to 1. Only then we get it. See, this is the total number of line. Na? Like, are you talking about key, sir? What I said, key, if you take 4, 1, 2, 3, 4, you are saying ki every line should come to this like
Yes.
this, right?
Yes. If n1 is equal to 1, it should come.
Yeah, like these are the three possible lines for sure. But when we calculate according to the n2 and n1, we are getting this number, na? According to formula, total number of lines. Oh, okay. You are right. But I understood what you are trying to say. Yes, sir. In case of Lyman series, n1 value is 1, na? So all the line will end up at the first line, right? This is what you are saying.
Yes, sir. Yes.
A- And if n1 value is 1 and n2 value is different, then if we calculate here, according to the formula, what will be the spectral line? 2 minus 1, 2, 1, 2 minus 1 plus 1, 1, 2 by 2. This was correct, na? Spectral line formula is n2 minus n1, n2 minus n1 plus 1 divided by 2. If n2 value is 2, n1 value is, what is the answer? Correct. Let's see here what will be the spectral line. 3 minus 1. 3 minus 1 will be 2 and 3 minus 1 plus 1, 3 divided by 2. So this was correct, na?
Sir, isn't it
Other-
1?
How? N1 value is 1 in Lyman series, but N2 value could be anything, right?
Yes, sir.
Ask me if you have any doubt. I thought I made a mistake in the calculation. Chandana, ask your doubt.
So 2 divided by 2 is 1. No?
Oh, this is the calculation mistake, but here it will be 1. Na? Yes. Tell me any doubt in any situation how we got this. Even I made calculation mistake in this.
Yes,
6
sir.
divided by 2, 3. Na?
Yes.
Earlier I wrote this right. How I made mistake here? I wrote only total number, not dividing by 2.
Yes, sir.
Yeah. So this was correct. That's how we calculate the total number of spectrum line. Key, how electron move from the higher energy to the lower energy. We are dealing here in the emission spectrum. This is emission spectrum. What does it mean? Emission spectrum means when any electron come from high energy to the low energy, it will emit some radiation. Okay. Example, here electron was present earlier, but it came down in the first shell in this region. It means it will emit some light, and same light we are representing in the form of like what is the number of the spectral line. Understood?
Yes, sir.
So let me know if you have doubt. Even because when I mentioned like many a time, if I'm teaching for so long time, I can make some mistake in the calculation or other concept. Let me know, I'll correct it if it is wrong. Okay, let's do question. then we'll understand better. First question. In hydrogen spectrum, if electron move from 7 to first orbit, then find out total number of spectral line. Total number of spectral line. Because Sanjana, remember one thing. You were thinking ki sir, it will come to ultimately N1, right?
Yes, sir.
In that situation, it will belong to only the Lyman series. But we are calculating total number of spectrum light. Then it can, example in this diagram, it can come to 2 or 3 as well. So we are calculating all, whether it is Lyman, Balmer, Paschen, Brackett, Pfund. We are calculating total number, right? That's why total number is different. Lyman series will be different. If anybody asks you what will be the number of spectral line in Lyman series 3, what will be the total number of spectral line? 6. Understood?
Yes, sir.
I think that is the main doubt for you, right?
Mm.
So it's good to keep asking doubt. Through that we get more clarity. Yeah, solve this question. Put formula and get your answer. That is the benefit. Ki you can understand lines through diagram also. You don't need to apply formula. But if number is high, like here, it will take lot of time.
So 21.
21.
Yes, sir.
Everybody got 21?
Yes, sir.
Yes, sir.
Remember, whatever is the number you get here,
Yes, sir.
you simply write one extra here. Example, n2 minus n1 is 6. Then next number will be 7. Make sense? So don't do lot of calculation. Whatever is the difference, next value will be 1 extra. Okay. If electron move from the 6th orbit to 2nd orbit, find out the total number of spectral line.
Sir, could you repeat?
I will write. If electron move from the 6th to 2nd orbit, calculate total number of spectral line.
Fifteen.
15.
No, sir. No, sir. I
There is a
calculated
10.
first.
Yes, it's okay. But now you can feel key how much time does it take. Whatever is the difference, just take extra 1 and divide by 2. So we'll get answer that. No need to use formula. Whatever, take difference, multiply with one extra number and divide by 2. You'll get answer. Do one more question. In case of hydrogen atom, if electron move from the nth number to first orbit in multi-step reaction, total number of spectrum line are 10. Calculate n value. Based on the above answer, 90% of question is done. Spectral line is 10. Here you will have x. Here you will have x plus 1. Whatever is the value, 1 extra. This is 2. 10 into 2, 20. So how you can get 20? One could be 4, another is 5. Difference is 4. So it will be 5. You got it, or should I explain from the scratch? And if you want to do it from the scratch, put simple formula n2 minus n1, n2 minus n1 plus 1 divided by 2. Example, n2 here, n1, 1. n2 here, n1, 1 plus 1 divided by 2 is equal to 10. This cancels. Okay, 2 will go to another side. n2 minus 1 and 2 will be equal to 20. Right? And if you multiply, it will be n2 square minus n2 will be minus 20 will be equal to 0. Now you can take algebraic equation. What is this equation then?
Quadratic.
B square quadratic equation. Yes. Quadratic equation. Done. But this will be easy. The total value will be 20. Correct? If you multiply other side, total value will be 20. So one could be 4, another will be 5. Because one value should be one extra than other. If you do by trick, it will be easy. If you do by formula, it will be lengthy and tough because you have to do quadratic equation. Should I explain this again? Like, what was the basic simple trick?
Yes, sir.
See, we said we have spectral line 10. N1 value is 1, N2 we have to calculate. In formula, N2 minus N1, let's assume this x. Then N2 minus N1 plus 1 will be x plus 1, like 1 extra. If it is x, another will be x plus 1. And it is 2 here. So 2 will go to another side, will become 20. Right? So just by hit and trial method, what could be this value? So another value is 1 extra and multiply is 20. You can take 4 and 5 only. Is there any other possibility? It means your x value will be 4. Done. ಅರ್ಥ ಆಯ್ತಾ?
ಆಯ್ತು.
Understood, everybody?
Yes, sir.
Yes, sir.
So this method will be easy. If you do quadratic equation, it will take very long time. And in exam, you don't have time. That is the ultimate thing. Whether you do physics or chemistry, especially these two subjects, you don't have time to solve numerical. And when I solve question, like what I feel support me is I try to avoid any calculation. Okay, I don't do calculation in
So can you go
physics.
back?
I don't do calculation in the physics because I know if I do it, it will take long time. It's practically impossible. So I try to play with the words, also the options, what are the options given, correct? It become really easy to make trick based on the option. Today I was doing a question from the chemical equilibrium. Okay, and there was a number k value was given, and then it like one x squared. Y cube, something like that was given. Okay, and you are supposed to calculate x value, and x option were 10 raised to power minus 63, 10 raised to power minus 31. Okay, and something like that. It was so far that you can easily get idea rather than doing calculation. If you do like this, it means it is impossible to complete the paper. Remember, this NEET exam is not just about the hard work. It's also about the smart work depending upon the demand of the exam. And trust me, you should know what is the trick of every question to solve the question quickly. If you feel your options are very close and you are supposed to do proper calculation, leave such question in the beginning. Solve question where you don't need calculation. At least out of 45, if you could solve 15, 20 question, like you are solving 20 question in 10 minutes, you will get enough time for other question where you are supposed to do calculation. Make sense?
Yes, sir.
Always follow this pattern. Two people. Anvita, I think you have network issue.
Yes, sir.
See, you are joining and you are there. You are everywhere.
Yes, sir. I don't know why this happens every time.
No, it happened with every single person. Like I have several, I've seen same thing with every person. So, l- very important topic, and even you got this question in NEET 2025 is Rydberg formula.
Sir, till when do we have this class?
Till when I have to finish this Rydberg formula, uh, wave mechanical model, dual nature of matter, and Heisenberg uncertainty principle. Probably a half an hour.
Okay.
Yeah. So, Rydberg formula. So there was a scientist, Rydberg. He said he, we can calculate the wavelength of different spectrals, but for single electronic species. Remember, this whole topic is about one electron system. One electron system. In this one electron system, if you want to calculate wave number, which is also equal to 1 by lambda, it will be equal to R Z square divided by 1 by N1 square minus 1 by N2 square. And this is extremely important. Okay. This value of Rydberg constant is taken in different form, but one of the most common value is taken 1 by R value is equal to 912 angstrom. Okay, 912 angstrom is one of the most popular Rydberg constant. in the reciprocal form. Huh? Any doubt?
No, sir.
Because here, whatever the wavelength you will calculate, you know if it is moving from N2 to N1, example from 2 to 1, here energy will be minimum, then your wavelength should be maximum. And if you are doing from N6 to N1, 6 to 1, then you will see energy will be maximum, then your wavelength value will be minimum. And trust me, based on only this, you can solve 80% of the question. You don't need to do calculation for that. And I'll show you in the NEET question. So write down question. How many questions we did? 3, 4. I calculate the wavelength of first line of Balmer series. Then what you need to understand is for Balmer series, N1 value is 2 and first line means N2 value is 3. See, if you understand the meaning of first line, half of the question is done. You know the meaning of Balmer series and first line. Balmer means N1 value 2 and first line means N2 value is 3. Sanya, if instead of first line, if you get last line, then what will be the N1 value?
So we can take infinite.
N1 value. And N2 value?
No, sir, we can take N1 as 2 and N2 as infinite.
Exactly. Whenever it is given key last line, always take infinite. Okay, last line, always take infinite. I will write here also. Last line, here, always take N2 value infinite. Okay, and if it is first line, from every system it can vary, but minimum value. First line means minimum, and last line means maximum. If you can do this, then apply formula. 1 by lambda is equal to R 1 by N1 square minus 1 by N2 square. 1 by lambda. You can, okay, R 1 by N1 value 2, 4, and N2 value 3, 9, 36, 9 minus 4, 5 by 36. So what will be lambda? Other side. Understood? Any doubt? Any doubt?
No, sir.
No, sir.
Next question. Calculate wavelength, frequency, and wave number for last line of. Don't do calculation. Like how I left it here. This is more than enough. Last line of Brackett series. Done. So, see, Lyman says N1 value 1, Balmer 2, Paschen 3, Brackett 4, Pfund 5. So this is bracket. It will be 4 4 the 16, and N2 value is infinite in this situation. N2 value infinite. So it will be 1 by infinite is 0. So this is the answer for the first answer, wave number. Wavelength ulta 16 into 1 by R, or 16 into 912 angstrom. Done. Correct. And if you have to calculate frequency, it will be C by lambda. So C is 3 into 10 raised to power 8, and lambda is 16 into 912 angstrom. Done. Tell me, guys, any doubt?
No, sir.
No, sir.
But remember, I'll do one thing. Most of people write like this, and here you can make mistake. Always write not R, R Z square, R Z square. People don't write Z. They don't have habit of writing Z, and that's what I always mention. When I am teaching you, na, what best I can give you, because the mistake you can make, because I am also making mistake. Okay, I will always focus where you can make mistake, and I can highlight that point more. Okay, so have this habit to write RZ square. Most of time will be given for the hydrogen atom, so it's easy, that value 1. But if they give for maybe lithium, helium, beryllium, carbon, anything of that sort, then you have to put Z value. Okay, so that's why Z, focus on this Z. Trust me, you will forget this. And tell me, Sania and Sania, yeah, you used to miss this Z square, and you remember R by R 1 by N square minus 1 by N2 square, right?
Yes, sir.
And you must have made mistake once or twice.
Yes, sir.
So this is what I will provide you. Ki I understand from the student perspective, not only teacher. Oh, I taught you, everything is sorted. Okay, so this thing is done. So this formula is enough to calculate the wavelength, frequency, and wave number. By the way, this new bar is equal to this is wave number. New bar is equal to wave number. So here you need what is the meaning of first line, what is the meaning of last line, what is the meaning of Lyman, Balmer, Paschen, Brackett, Pfund series. That's all. So these are the advantage ki we can um, get full study of hydrogen and hydrogen-like atom. But what are the limitation of the Bohr model? Because there must be some limitation also. It was not one of the perfect model. So what are the limitation of the Bohr model? Because this is given ditto in NCERT. That's why we have to study this. First, biggest problem is applicable only to one electron system. Only to one electron system. If you have multiple electron system like oxygen, zinc, aluminium, or anything of that sort, it is not applicable. Correct? Angular momentum is equal to L is equal to mvr is equal to nh upon 2 pi. But how? This how was not explained. Okay. How angular momentum is equal to nh upon 2 pi, he did not explain. Any doubt?
No,
Third, Bohr theory does not explain the spectral line structure, like what happened in the different structures. Correct? Like through the spectroscope, we can study in detail, but he did not provide any evidence, any proof ki what happened to the spectral light. And last line, and very important because this specific term is given in NCERT and extremely important. Bohr theory does not explain the splitting of the spectral line. Does not explain splitting of spectral line. Okay. Example, in presence of magnetic field, splitting of spectral line is known as Zeeman effect, and in electric field in the Stark effect. What happened? You have many spectrum line. These spectral line will split further in presence of magnetic field and electric field. In presence of electric field and magnetic field, these lines will break. So, in presence of magnetic field, same effect is known as Zeeman effect. Pure theoretical question. There is no logic behind this. And this is the Stark effect. What I can explain you, if you have strong influence, then this line can break, their energy can change. How this energy change in presence of magnetic field and electric field is not explained by the Bohr model. Okay, and if you know this, you can solve many questions. Yesterday I sent you PDF of this question in the group, right? Yesterday I sent you gravitation biomolecule. I didn't send you this atomic structure PDF.
Yes, sir.
I did, right? Biomolecule, work energy power, work energy power. One concept. See, 2019. Which of the following series fall in the visible region? Sarah.
The Lyman. Oh,
Lyman UV. Balmer visible. Remaining all infrared. Remaining all three infrared. See, this is pure. Like you are not supposed to do calculation. Least energy is present when it is close, like from 1 to 2, 2 to 1. Correct? Minimum energy. If 6 to 1, then maximum energy. Can it happen? Can C happen? Yeah, it is possible. Minimum energy. The more will be the value, energy will be the minimum. Understood? The more you are keep going away, your value will reduce. Correct? The more you are going away, your value will reduce. How? I'll show you from the PDF. If you see in this yesterday, see, if you take difference between 1, 2 to 1, it was difference 10.2, very big difference. But if you take difference from 6 to 5, difference will be very less. Only zero point 0.2. Tell me, it's easy to understand now? Anjali, hello, हेलो, बहुत बढ़िया. क्लास लेने लग जाता. अच्छा, हाँ, बस खत्म होने वाली हो रही है 10-15 मिनट में. हाँ, हाँ, फिर सामान दरवाजा करना तो जुगाड़ दा बचा करा. कितना भारी है? अच्छा, फिर आधा घंटा मैच ही. ना ना, क्योंकि 15-20 मिनट तो क्लास में लग जाएगी. 15-20 मिनट तो क्लास में लग जाएगी. क्लास में 15 मिनट आ जाए फिर. हाँ, हाँ, थोड़ा फिर.
कर देंगे.
Understood, guys? This difference key. I told you key here you can see difference is very big between 2 to 1. Though energy will be minimum compared to other. Compared to from 6 to 1, this is less. But overall, it is more when it comes to this difference. But if you see difference between 6 to 5, from 6 to 5, difference will be very less. Yes or no, guys? Understood? Why I did this today as well as yesterday. See, yesterday I told you same thing. I told you, I think, same thing yesterday also. Why I feel like I taught you this before? Energy difference. Yeah, see, yesterday I gave you this difference. Here difference, as you go away, difference keep on reducing. This is how you learn through the question. It means if you take difference between E2 and E1, it will be greater than E3 to E2. We wrote this before also, I guess. Then it will be greater than E4 to E3. It will be greater than E5 to 4. 5-10 मिनट रुक जाओ मैं आ जाऊंगा. And like same way E6 to E5. Understood? So where you have minimum difference in E5 to E6? Yes or no, guys? Correct.
Yes, sir.
So this is how you learn through the question. See, if you keep solving all the four, trust me, it will take minimum 5 years. Tanya, tell me, last year you used to do individually and it was taking very long time
Sir, it used to feel confusing and sometimes pathetic.
and, and lengthy. You are solving each one and then you are calculating energy.
Yes,
What will
sir.
be the exact amount? Then you compare the energy. Right? So this is the problem. Ki student think in general, not you, because you trust me, so I feel good about this and I feel responsible. But in general, the biggest problem for a student not getting selected is not because they are not reading. The only reason is they think they can do by themselves, by their own planning. Example, if you are doing it and you spend 10 minutes or 5 minutes on this, still you will not be sure about the answer. And here it won't take more than 10 seconds. Just look at the number. Minimum difference will have minimum energy. And if difference is same, then you will look for the maximum value. Understood? Two rules. First, the difference. Example, in first situation, 6 to 1 difference is very high, so energy will be maximum. Right? In B and C, difference is only 1, so energy will be minimum. Now you have to eliminate out of B and C which one is the right answer. How to do this? See, whichever value is high, energy will be minimum. Understood? That's what I say. Ki here, if you calculate, not it will take lot of time. Seventh question. Here, all the value are very close to each other. How to calculate frequency? Frequency, you can calculate, frequency is equal to C by lambda or C into nu bar because 1 by lambda is equal to nu bar. Again, this is equal to C bar. And C, this 1 by bar will be equal to R, uh, N1 value 1 and N2 value 16. So it will be 15 by 16. So frequency, you can calculate C value 3 into 10 raised to power 8, R value, and then 15 by 16. 1 by R is equal to 912 angstrom. Now you will see how much time it is taking to calculate because powers are very close to each other. Understood? Yes or no?
Yes, sir.
Mostly उसका क्या इंटा का मौसी इंटा का के रहा। हाँ हेलो। बहुत बढ़िया भाई, आपने सुना। भाई क्या था, मौसी ने कब थे आज आवेगी, मैं उससे अगर बात करके बताऊं देना क्यों गया। हाँ हाँ। अच्छा ईंटों थी और मसाला ढोना था। अच्छा यार कि मेरे बहुत पूछे थे। तीन कमांड में तो आपने ईंट कर दिया, कुछ ईंट सही भी है। तो वह ईंट कड़ा काम आवे, क्योंकि जे नहीं क्या माई नहीं तो अपना जीना आराम हो जाएगा। हाँ। उनने न्यू लग गया नहीं, ये इतनी ठगल चीज तो आज तक दुनिया में और ये कौन सी उस जमाना से इतनी। हाँ हाँ, क्योंकि ये बैठक में मसाला यो रोड़ा घेर दिया। ठीक है। हाँ इसका तो रोड़ा अच्छा हो रहा है। अरबी तराड़ा खाली कर दिया। और गन्नों गवर्नमेंट तीनों गवर्नमेंट जाली। हाँ तीनों ब्रांड वाली भी तराड़ी रोड सारी। हाँ। तो फिर मैं इंटा का एक बुक पूछते थे तो थोड़ी देर में बताऊँ कि आज इंट का क्या होगा। ठीक है, थोड़ी देर में तेरा तेरा फोन करो। हाँ हाँ हाँ। कसी है, तसड़ी खरीदनी है तो लेनी तो है वैसे भी। ठीक है, मैं वो तेरे तो थोड़ी देर में बताऊँ। ठीक है, जल्दी से जल्दी। एनी डाउट गाइस, यू गॉट आंसर? यू गॉट आंसर? एम आई ऑडिबल?
Yes, sir.
एनीबडी गॉट आंसर?
So 3 into 10 power 50.
10 to 10 raised to power 15, C.
Yes, sir.
All of you got this answer?
Sir, option D.
Option B, 1 into 10 raised to
D.
power. D,
D.
2,
D.
2. All of you got this?
So 3.08 into 10 raised to 50. C, option C.
Option C. Answer will be C. You can use calculator, but this question, this calculation over length, you don't need this H and all stuff, but calculation was lengthy. First, you need to calculate wavelength, and based on the wavelength, you can calculate this. But wait, I want to see one thing. Can I make it fast? Wow. Guys, you know how you could solve this question? This is the longest method. Easiest method is this is energy given. This is H value given. Energy is equal to H nu. Nu is equal to E by H. Can you write it 21.8 into 10 raised to power minus 19? Divide by 6.6 into 10 raised to power minus 34. It is approximately 3. It will go up will become 10 raised to the power 15. Tell me. Tell me. Make sense, guys?
Yes, sir.
Yes, sir.
That's why even I never have any trick. It's just I try to observe them more and see what we can do in the easiest way. First, I do always in the longest way to understand that sometime we can get tough question and we have to do calculation. But at the same time, you should not trick. Okay, energy is given, A is given, and A is equal to h nu. Then direct calculation and don't do exact calculation again. Same. It is approximately 21.8 divided by 6, almost 3 and 15 because all value are given in 15. Then now you took 2 minutes and this calculation took not more than 20 seconds, right? That's
Yes.
why I said key. Nobody can prepare for NEET by self-study. Maybe your effort is always required to make it best, but you should know how to see here longest. You are looking for the longest wavelength. Whenever you have longest wavelength, it means there is maximum wavelength, minimum energy. And energy is minimum when you have minimum difference in the Balmer series. Balmer series and when value is 2 and 2 value will be 3. Correct? See, same question is given. Got it? Now tell me out of these 4, where you have maximum wavelength? What do you guys say? Make make sense?
Yes, sir.
But it does not mean that you will not do long method. For practice, you should always do long method, and then in the final exam, like just 1 month or 2 months before, you start practicing for the shortest one. Ki how I can make it the shortest. Understood? Even if you read the range of the wavelength of every series, you will get idea what could be my answer. You should. I'll tell you. Ki in Lyman series, what is the range of the wavelength? In the Balmer series, what will be the range of the wavelength? You will get idea. Okay, my range could be this. Any doubt? And with this, we finish all the questions, and these 19 questions are done. This dual nature of matter. Oh, it is 5 o'clock. I'll finish this dual nature of matter in maximum half an hour with question. So it will be very short. Tomorrow we'll finish this chapter because preliminary model and dual nature of matter is very small. Only 10 questions. Remaining thing we did dual nature of matter quantum number. Okay, so we are done with this. We are done with this. This part is very small. This is extremely small. Tomorrow we'll finish this, and tomorrow we'll finish gravitation both. So do question and see you at 6 because it's already been 5 o'clock. Okay, guys. I hope you understood every question.
सर नेक्स्ट क्लास कब है
6 o'clock.
सर वो आपने जो समझाया कि E2 और E1 के बीच में जो एनर्जी डिफरेंस है वो E3 और E2 के से ज्यादा है सर, वो वाला
हाँ,
पार्ट थोड़ा वापस समझा देंगे?
वो वाला पार्ट एक बार क्वेश्चन करना, मैं कल इसको समझाऊंगा। जैसे मैंने ये किया ना, मैंने कल ये सेम कॉन्सेप्ट यहाँ पे किया था। ठीक है, तो जैसे मैंने यहाँ पे डिफरेंस निकाला था और मैंने निकाल के जब ये निकाला तो ये बताया कि अगर E1 और E2 का मैंने डिफरेंस लिया तो ये तो 10 आया। लेकिन 3 और 2 के बीच का डिफरेंस आया तो बहुत कम आया, और 4 और 3 के बीच में तो सबसे कम आया. So as we are going higher from 4 to 3 or 5 to 4 or 6 to 4, it will keep on reducing, and you can see through the data. You're not supposed to remember data, but this is how it works. Phone. Understood?
Yes, sir.
Sanya, should I
Yes,
explain this again? In
sir.
case of E2 to E1, 10.2, but E4 to E3, only 0.66. And if you go further, it will be the minimum. Understood?
Yes, sir.
Sanya?
Yes, sir.
Yeah. So, let me know if anybody have any other doubt. Go through it. You will have doubt again, and let me know in next class. Okay. See you then. See you at 6, and I'll write in the group you will have class at 6. Okay. Bye, guys. And send me your notes first. I'll check notes in group right now.